Okay. Hello, everybody, and welcome to BSidesCLT. This is Ali Kabeel, and today we will be presenting breaking the giants with application-level denial of service attacks. So before we start, let's look at some who am I. I'm a computer science and engineering student at the German University in Cairo. I have been a bug hunter and a security researcher since 2014. My research interests mainly revolve around privacy, web application security, and network security. I'm especially interested in business logic vulnerabilities and logic-based vulnerabilities in general. I have been a speaker at BSides Las Vegas this year, as well as the IEEE LCN. You can find me on the social media at Logic Breaker on Twitter and at Kabeel on LinkedIn. So let's kick in with some motivation regarding our topic. So our topic is breaking the giants with application-level denial of service attack. So let's break this title up into smaller pieces just to get a hold of it. So the first thing is breaking the giants. And by the giants here, we refer to gigantic companies, examples like Facebook, Google, Snapchat, and those big companies with huge infrastructures and so on. And let's then go to the second part, which is application-level denial of service attack. So before we dive into the application-level denial of service attack, it's important to make sure that everybody here would understand what a CIA triad is. So the CIA triad is like the golden standard set by information security professionals. They are like the goals that any system should aim to achieve just to be called secure. And actually, it consists of three main parts. The first part, which is the C in the CIA, which is confidentiality. So what do we mean by confidentiality? Confidentiality means that whichever information which is considered secret stays within the system. It doesn't go to any unintentional malicious or adversaries. It doesn't go outside in general. It doesn't have to be to a malicious person. And information that's meant to stay within the system should stay within the system to be called confidential. Otherwise, the confidentiality of the data is not guaranteed. The other part, which is the I in the CIA, refers to integrity. And what we mean by integrity is that the data is unaltered and it's not changed or manipulated with. So what's an example of that? So for instance, if you have an account like an account on Facebook, for instance, imagine that you are logging in and you say that your name is changed, for instance. Your data integrity have been affected. Somebody maliciously altered your data. Your data is not authentic. It's not the data that you saved, the data that is meant to be in the service or the system itself. So here we know that there is an integrity problem. So we say that the data is integral if nobody altered this and it's not tampered. And finally, we go to our target, and the target of denial of service attack, which is availability, or the A in the CIA triad. So what do we mean by availability? The service or the server or with the system is set to be available. It's able to serve its customers, to serve its users. Users are able to utilize the system. So imagine that you go to a website and then you are trying to log in, and whenever you are trying to use the website, it's giving you an error or it's timing out, it's not working. The system is not available. And maybe the system is under attack or it is in maintenance mode or something, but it's not available. And the system that's not available is actually a system that's not useful. Imagine that the website is not available for you. So even if it is the most confidential and the best integral website that ever existed, if you can't use it, it's no use at all. So before we go into application-level denial of service attacks, let's go into the more conventional way of denial of service attacks and talk more about denial of service attacks. So denial of service attacks refer to the attacks that aim to disrupt the availability of the system. Whenever we talk about denial of service attacks, we talk about the attacks that aim to make the system unavailable. Maybe it may aim to make the system completely unavailable, or it may aim to make the system partially unavailable, or make the customers incur huge penalties. So imagine you are visiting a website and it takes like 3 to 4 minutes to load, so you just close the website because it's not useful to you anymore. It's not that responsive that you use. This website may be under a denial of service attack, aiming to make the users or the benign and legit users not be able to use the system. So how was this done in the past? So in the past, people used brute force to do that. They used what we call a high volume denial of service attack. High volume attacks mainly aim to send a huge amount of requests to the target server or to the target system. So the server and system will be very busy handling those requests, and it won't have enough time to handle the benign user's request. So when the benign user's request, or by benign we mean here legit, will not be able to be handled promptly. So For instance, if a server is made to handle like 100 requests, we are sending like 1,000 requests. So now the server can't withstand this amount. So some of the requests will time out, and the others will just incur huge delays, making the system unavailable to the legit users. Actually, this was usually done using what we call the distributed denial of service attack. So a malicious user or the malicious attacker will just get control of a huge amount of computers, either using malware or otherwise, and use them to launch the attack. It's not just a single computer, it's more of a distributed network of computers or a distributed network of devices. Actually, this still exists, and it was proven to cost companies billions of dollars, because one day, if, for instance, Twitter is not available, it means that it will lose a huge amount of money. But this began to change. The question is, why did it change? Wasn't it effective? No, it was effective. But the idea is the rise of intrusion detection systems and solutions like Cloudflare, for instance, made denial of service attacks less harmful. So you need to be extremely brutal when you conduct a denial of service attack to attack the system. Also, attacking something like, for instance, as big as Facebook, you won't be able to send enough requests to get Facebook servers down, because at the end of the day, you won't be having enough computational capacity to do so. A huge amount of servers, a huge elastic databases that are not easily taken down. So brute force is not useful in those situations. And we are beginning to change to the modern application level attacks that we will be tackling in a second. So before we move to the application level attacks, let's take two examples for the high volume conventional attack. So we have the SYN flood attack and the ping flood attack. So the SYN flood attack refers to a vulnerability that existed in the TCP protocol. So whenever you are attempting to connect to a computer using the TCP protocol, you send a SYN packet. The server will reply with a SYN ACK packet, and then the connection will be established once you reply with an acknowledgement packet. So it's called a three-way handshake. You send a SYN, you get a SYN ACK, and then you send an ACK. So if I'm an attacker, what I will do, I will just send SYN requests. The server will reply with SYN ACK and will wait for acknowledgement packets, but they will never get them because I will never send the acknowledgement packet. So what happens is the server has a connection capacity, an amount of connection that the server can maintain or can withstand without actually going down. What I'm doing is I'm consuming this capacity. I'm sending 10 requests. The server opened the connection and he's waiting for me after sending a SYN ACK to just send him an ACK, but I'm never doing that. So I'm ultimately using the connection capacity of the server, and this will not allow benign users to connect if I ultimately manage to just fill all the connection capacity of the server. The other thing is the ping flood attack, and the ping flood attack is an ICMP protocol attack. Simply, whenever you send a ping attack, the server receives it. So this actually consumes the incoming bandwidth of the server, because I'm sending a request, the incoming bandwidth is being consumed. But there is something that's even worse. You send a ping packet, and then the server will have to reply with what we call an echo ping packet. So you are not only consuming the incoming bandwidth, but also the outgoing bandwidth, because the server will have to be busy serving your echo ping packet. So you are consuming both the incoming and the outgoing. This will ultimately cause the system to not be having enough time or resources to serve benign users, and will make the system unavailable to them, causing denial of service attacks. So let's go into our topic of application level denial of service attacks, and let's start by some theory from our friends at WASP and Fort Swigger. So what's application level denial of service attack? So what we have been covering so far is related to the network layer. Usually we are targeting the network part of the application, either using something like a SYN attack or a ping slot or otherwise, but we are targeting the network layer. Then application level denial of service attack refers to a class of vulnerabilities that exists in the application. The attacker are targeting vulnerabilities in the application layer of the service. It is the application itself. So whenever the attacker found a vulnerability in the application that may cause the server to go unavailable to user, this is an application level denial of service attack. It is something related to the application itself. And it's very unique that it can differ from an application to an application. It is not just like a SYN flood attack, which can happen anywhere using TCP. Application level require users or require security researchers to dig very deep to find those vulnerabilities, to exploit them, or even to patch them. So they are not easy to find and not easy to patch because they vary from one place to another. A very famous example is what we call the resource locking on failure. So what is the resource locking on failure? So the resource locking on failure is a vulnerability that may occur because whenever a server hits an error, instead of just releasing the resources that was used by the user that caused the failure, the server will lock those resources. So let's clarify this point. Imagine that you are doing some calculations on any server, and then, for instance, you caused some failure by dividing by 0, for instance. So the server has a failure, but you were using some part of the server to do some calculations. So the logical thing that can happen is that, okay, we will just go on and release those resources so that they can be used by other people and so on. But this doesn't happen. The service will say, okay, a failure happened, so this part of the server will not be utilized and people cannot use it. So what happened here is an application vulnerability, which is something like dividing by 0. It's not a vulnerability, it's just a failure. Dividing by 0 caused the server to make some part of it unavailable. It's locked in the failure, nothing can happen, nobody can use this. So if I'm malicious, I may induce the failure that will cause the system to ultimately lock all of its resources into failures. So the system resources will be locked into failures, nobody can use them, the service is ultimately unavailable for anybody. A nice class of application level denial of service attacks, and one of the known ones, is called the second order denial of service attack. So what is the second order denial of service attack? Before we answer this question, let's take a step back and look at something like a second order cross-site scripting attack or second order access. Second order here refers to the fact that it is stored. Second order cross-site scripting payloads are usually stored in databases or something, and whenever a user visits a certain page in which the information is rendered, this information gets retrieved from the database and the payload fire. So the idea here is that the data used in the attack is stored inside a database or inside the application itself. And denial of service attacks or second order denial of service attacks are no different. We refer here to the fact that the data used to launch the denial of service attack will be on the service. It will be a part of the database, stored in a database. It will not cause the denial of service attack until we do some action that triggers the denial of service attack behavior. So let's take an example to understand what we mean here. Imagine having something like Pastebin where you can create random paste. Imagine that Pastebin has no methodology that limits the amount of paste that you can create. So you just create unlimited amount of paste. You create 10,000, 10 million, or whatever amount you want of paste, and then they are stored in the database. First of all, you are filling the database with garbage because simply you have automated the process. It's not real paste. Nobody is using those paste. They are just garbage. So you are consuming the database. Maybe it's a cloud database, and then you are consuming money. But there is another problem here. Imagine that now you go into account, and then you go to the paste tab, and you want to see your paste. What happens is the server will go to the database and ask it to retrieve all the paste that this user has. And this user has 10 million paste, for instance. So what happens is the server will attempt to retrieve 10 million records from the database. This is the huge amount of resources required to retrieve this amount of information. It's also a huge amount of time. So imagine retrieving 10,000 records. That's insanely big. What happens is one of two things will happen. The first is the server will limit the amount of data retrieved. So for instance, I will only retrieve you the first 100. And it is the correct way to do things, because if the server doesn't bound it, here we have what we call a linear time operation on the data. So we have 10 million records and we are retrieving them. It's expected that if we have 20 million records, the time will double, because let's say that the record will be retrieved in approximately constant time. So the idea here is we should never allow the user to induce some kind of linear time operation or complex time operation in general, something that's not O of 1 or it's not constant time on the data. Otherwise, whenever the user will attempt to retrieve this data, simply the user will render the server unavailable due to the huge amount of resources consumed to serve the user request. Taking it from here, let's take a little bit on some of the case studies. One of them will be about the second order denial of service attack that we just discussed, and it is in Snapchat developer portal. And the other will be about fooling Snapchat API to achieve targeted denial of service. It's not related to second order denial of service attack. but it's related to application level denial of service attacks that we discussed before. So let's go into the second order denial of service attack on Snapchat. So Snapchat had a developer portal. You have an organization, you can add developers and so on and so forth. And the idea here is that you can add applications into this organization. So you can simply create an application within the organization, and there was no limit on the number of applications that you can create. You can create 10,000 applications, 10 million applications, whichever number you seek. In addition, you can add anybody to your organization without any kind of authorization. They won't authorize you. You just type in their email. They are already added into your organization, and there is no way that they can get out of the organization. Actually, there was no leave organization button either. So this is itself a vulnerability. You are being able to add people forcibly to your organization, which may be offensive to them, but this is just a part of our problem. The other part is actually the unbounded amount of applications. Let's say that I created 10,000 applications and added my victim to the organization. What will happen when the user logs into the developer portal? Once the user logs into the developer portal, the server will attempt to retrieve all the organizations of the user and all the applications to load them just to make his life easier whenever navigating the website. So what will happen is that the server will go and tell the database, okay, load all the applications. And there is 10,000 applications. So what Snapchat did to avoid that unbounded linear time operation is that they cause a timeout. So whenever the data is huge, instead of just retrieving the first 100, for instance, they will just time out. Of course, they have a timeout of like 15 seconds, and 10,000 applications would not be loaded in 15 seconds. So whenever the user log into his developer account, it will just tell him that the server is not available, simply because the server can't load his data. And this will not only deny him from accessing our organization, he never meant to access our organization. It will deny him from accessing his whole account. He can't navigate his account, he can't use it at all. The developer's account is useless for him. Whenever he uses 500, server is not available, I'm sorry. If the victim account is now useless, he will have to contact, for instance, the support or something and tell him his problem. Maybe it gets solved and maybe not. And once it gets solved, we can just re-add him, and again, his account will be closed. So just by knowing the victim email, we can do this attack. We can even automate it on many number of users by just using random emails, for instance. Or if we have a way to enumerate emails, that will even boost the effect of the attack. So this is the first attack and how we were able to deny people from accessing their developer's account. Let's move on to the other interesting attack, which is how we were able to deny people from accessing their business accounts on Snapchat. So the business account, which is actually linked with the developer account, but they are two separate accounts at the end of the day. It has a nice feature to invite people, and now Snapchat were a bit smarter, and they allow people to accept or reject invitations. So whenever you send an invitation, they can accept and reject. They will not be added automatically. So what happened is you can send somebody an invitation, and whenever you send him an invitation, if you are using something like a proxy like Verb Suite or something, whenever you send the invitation, the request coming after the invitation aim to assign a role to the user. So it aims to just make the user have a new role or something in the organization. Maybe you assign him a developer, an organization admin, or whatever. But what I thought about, what will happen if the user has no role at all? We will just drop the request. What happened is, whenever the user logged in, he sees our invitation, but then whenever he clicks on that invitation and attempt to join our organization, he won't be able to join it, and his account will be locked forever. Why? Because this is how the API functions. The API will look into the user account. Are you a part of this organization, which is the attacker's organization or my organization in this case? And the answer is yes, I'm a part of this organization. They accepted our invitation. But then the second question is, do you have any role in that organization? Are you a developer or an organization admin or something? And the answer is no, you don't have any role. So what will API do? Instead of just denying him from accessing our organization, which makes sense, the API closed the whole account. It say, okay, I'm sorry, this is not allowed. You are not authorized to get into your account. So all the functionalities within the account were rendered not available. You will just see a screen telling you, I'm sorry, you are not authorized. Even his own organization, he will not be able to access them. This is because the API was not functioning incorrectly, and that's how we denied the users. Somebody would say, okay, I see you, but you have said that the user needs to accept the invitation. This is not a zero-click attack. Okay, you are right. But if we move the step back, I told you at the beginning of the story that the developer's account was linked with the business account. Luckily, whenever somebody is added as a developer, they are added automatically to our business account without any kind of acceptance. So how did I just escalate that further? You go to the developer's account, add somebody to your organization as a developer, and then you navigate to the business account, they are added automatically. There is no need for the invitation, no need to accept it, and now whenever he logs in, he can't access his account without touching the invitation or accepting it. So this is how we escalated it from something that needs the user to accept our invitation to something that needs absolutely no user interaction. So this summarizes the API pooling and how we were able to deny the users from accessing their business account. Finally, I would like to share some final thoughts regarding the topic about how to find and exploit application-level denial of service vulnerabilities. And the main way to find those is to actually look at previous vulnerabilities. Those are just like business logic. They are not easy to find, but they happen to be similar between applications having similar businesses. So for instance, if you find a way to do that in a social media application, just look the same way in other social media applications, because maybe you'll find them. Also, there are some clusters or classes of application-level denial of service attacks, like the second-order denial of service attacks. And then you can just look for it the same way you look for second-order denial of, second-order cross-site scripting and so on. So it's not really that hard. But the main thing I will tell you, you will have to understand the application, to understand the application technology, how it is functioning, and how can you render exceptionally long delays in it. This is your way to find and exploit those vulnerabilities. About my future work, actually, I'm now working on studying the attacks regarding microservice networks, which is an emerging system architecture. I'm working on understanding the architecture more and looking into how to find unique denial of service attacks within that architecture. And I'm working on doing that in the moment. So finally, I would like to thank Chembox. Chembox was my mentor in my first ever talk. Without him, I wouldn't have done it here. I would also like to thank at Symbian Timo, at Zigo, and at Fairmatrix. Those people mentored me at my start, and actually without them, I wouldn't have gone that far. So I would like to thank him, and I would like to urge you to follow those people on Twitter, because they usually share things about security, and you are probably going to learn a lot from them. I would like to finally thank you all for attending, and I would be happy if you have any questions to answer them. Thank you, everybody.